Well, there's the bell, so it must be 10 o'clock. This hearing will come to order. I hear the bells ringing, so it must be 10 o'clock, and I'm following Senator Glenn's suggestion that in his committees, he knows how things are often hectic. You need to get started on time to encourage people to get here on time. We have members at various other hearings. They'll be coming and going, but I want you also to know, we want to welcome all of our webcast viewers today. We typically have, it's really hard to believe, but we'll have 2 million or more individuals watching us on the web today, so we want to welcome all those too. And I will be brief in my opening remarks because we have a very distinguished panel of witnesses, and I know that we all want to hear from them. However, I do want to provide some context for today's hearing. As many of you know, this year marks the 50th anniversary of the creation of the Science and Technology Committee. We were one of Congress's responses to the Soviet Union's successful launch of Sputnik 1 in late 1957. Sputnik led to a national reexamination of America's educational system, our scientific research infrastructure, and our goals and capabilities for space exploration. And this committee was given the responsibility of leading congressional oversight of these issues. 1958 also marked the year that the National Aeronautics and Space Administration was established. In fact, yesterday, July the 29th, marked the 50th anniversary of President Eisenhower's signing of the National Aeronautics and Space Act of 1958, the legislation that created NASA. So it's fitting that we take time to look back at what NASA has accomplished over the past 50 years, as well as look ahead to the opportunities and challenges facing the agency over the next 50 years. We often forget how much we owe to the men and women of NASA, who in many ways have helped create the world in which we live today. They have dramatically advanced our knowledge of our home planet Earth and of the universe at large through an amazing array of scientific research or spacecraft over the past 5 decades. Indeed, it's no exaggeration to say that NASA's accomplishments have helped to rewrite the science textbooks more than once. NASA's men and women have also helped create the technologies that have made possible the commercial aircraft and the aviation system that contribute so much to our nation's economic vitality, as well as technologies that have helped enable the military aircraft that defend our freedom. Finally, NASA's men and women have led the way in helping humanity to move out into the solar system, including putting the first footprints on the moon almost 40 years ago. In doing so, they've inspired successive generations to seek to achieve challenging goals in science and technology. In short, NASA has accomplished a great deal in its first 50 years. Of course, the agency has also had its share of tragedies and missteps over that same period, and we will continue to address those issues whenever it's necessary as part of the committee's ongoing oversight of NASA. But at the end of the day, however, NASA and its programs are still recognized around the world as the shining symbol of America's preeminence in science and technology, and we need to ensure that continues to be the case. In that regard, I'm pleased that the House of Representatives passed the committee's bipartisan NASA Authorization Act by an overwhelming margin, because I believe the bill will help provide positive guidance to the next administration regarding the importance of investing in our nation's civil space and aeronautics programs, and investing at a level that is equal to the task we've asked the agencies to undertake. I look forward to the Senate completing its work on the bill so that we can send it to the President for his signature before Congress adjourns. I also want to express my deep appreciation to the noted physicist, Professor Stephen Hawkins, for his submitting a pre-recorded message that will be played during this hearing. However, before we hear from the witnesses and Professor Hawkins, I also want to recognize some special guests we have in the audience today. I'm very pleased that 2 former chairmen of the Science and Technology Committee, Bob Walker and Sherry Bowler, are able to join us today. In addition, I would also like to recognize NASA Deputy Administrator Shanna Dale, who has joined us today also. So welcome to each of you, and thank you for your contribution to this committee and to Congress and to NASA. Now I'd like to return to my friend and colleague, Ranking Member Hall, a longtime strong supporter of NASA, for any opening comments that he would care to make.
Mr. Chairman, I thank you, and you've made good comments, and it gives me great pleasure to be here today. NASA has given us so many really great accomplishments and such pride and so many great American heroes. And today we're honored to have Senator Glenn here, who is certainly everyone's hero. Spent a lifetime serving his country, first as a naval aviator, then as an American, the first American to orbit the Earth, and serving 24 years as a U.S. Senator from Ohio. And I was proud to be on the elect John Glenn president for a long, long time in Texas. And they still, half the people there think he won. So, and the very lovely Mrs. Glenn, who would have made a great First Lady. We're glad to have you with us. I also am pleased to see other distinguished Americans on our panel today. Norm Augustine, a good friend and longtime supporter of everything that's good and great for NASA and for the American people. My recommendation to either of those presidential aspirants for a vice president, if we could push you into it, but I know we couldn't, because I suggested it to you and you said you thought I was your friend. Speaking of Norm, the American people really should feel at ease if we could accept that second spot. We'll talk about that later. Dr. Stephen Hawking, I also want to take a moment to welcome my good friends and former colleagues, as Bart has done, Bob Walker and Sherry Bolett, who, along with Jim Sensenbrenner, and have ably chaired this committee. And I'd also like to mention the chairman I've worked with here who could not make it here today, Don Fuqua, what a guy, and Robert Rowe, and the late George Brown. So it's really fitting to reflect on the accomplishments of both NASA and the Science and Technology Committee. Dana, we're happy to see you and glad to see that you're still running NASA. We look to you for leadership, as you've given us for a lot of your years. I think first time I ever saw you, you were working for NASA, you were on a tricycle. That's how long you've been with us, so I won't mention the number of years. But welcome to you. In the decade after World War II, American leadership in science and technology was largely taken for granted, and we may have allowed ourselves to get too complacent. When the Soviets launched Sputnik in October of 1957, I well remember it. I watched it, and it was a real wake-up call for the country. In 1958, under House Speaker Sam Rayburn, who's Texas' 4th District, I proudly represented at this time the Select Committee on Astronautics and Space Exploration was established. Excuse me. Shortly thereafter, the committee created NASA from what was then the National Advisory Committee on Aeronautics, and the Permanent House Committee on Science and Astronautics, or our forerunner, was chartered. We rose to the challenge of Sputnik. We caught up with and then surpassed the Soviets, and in doing so, we demonstrated to the world our American values of democracy and peaceful scientific achievements, but scientific and technological advantages tend to be short-lived, and they rely on a steady stream of education and innovation that must be nurtured. While we celebrate and reflect on NASA's past accomplishments, it's also clear that the future challenges and opportunities are no less daunting, no less important, and no less inspiring than those of the last 50 years. NASA's astronautical program are vital as developing the next generation of aircraft and air traffic management systems that will help expand our economy through increased capacity with less frequent and less costly delays, and by developing technologies that will enable safer and more efficient aircraft. NASA's space science programs contribute to our knowledge of our solar system, the sun, and the universe. Space science has always been very practical and has had practical applications, developing the means to monitor solar space weather events, which can disrupt the transmission of GPS signals and satellite communications and interfere with ground-based systems such as our electricity grid or our military weapons targeting. So, finally, NASA's Earth science programs have greatly advanced our understanding of our home planet. We're beginning to better understand the Earth and the ways that weather, the oceans, land masses, ice caps, and the atmosphere interact with one another. Through NASA-developed technology, we're also improving our ability to predict weather, help farmers increase crop production, give local governments the ability to better manage land use, fisheries, and many other practical uses. And in human space exploration, NASA is completing construction of the International Space Station. The ISS is the largest international engineering and construction project ever undertaken, and research on board station holds the promise of life-changing medical breakthroughs. We'll pursue many of our future space exploration challenges with our international friends and allies, and those arrangements offer the potential for sustained, peaceful cooperation in both science and technology. If America wants to retain its status in the world and the prestige and power that comes from leadership, we cannot be complacent. Other countries are making great strides, and American leadership is not guaranteed. We can succeed at whatever we put our minds to as long as we stay focused. Mr. Chairman, I look forward to today's hearing. I look forward to celebrating some of our past successes. I also look forward to hearing from our panelists how we can all work together to ensure that the next 50 years are even better. I'm proud to have been a part of the Science and Technology Committee for 27 years. Together we've accomplished amazing revolutionary things. You've given us good leadership as our chairman. We're the leading committee in the United States Congress on successful transmitting bills that come before us and handle them properly, and I'm confident that our finest hour is still ahead of us. Thank you, Mr. Chairman.
Thank you very much, Mr. Hall. If there are members who wish to submit additional opening statements, your statements will be added to the record. And at this time, I will now introduce our witnesses. First up will be the Honorable John Glenn, who was the first American to orbit the Earth as part of the original Mercury 7 astronauts. He then served the state of Ohio as senator for 24 years, and in 1998, Senator Glenn returned to orbit as the oldest person to fly in space as a crew member of the Space Shuttle Discovery. And Ms. Glenn, we welcome you here. Secondly, we'll have Dr. Norm Augustine, who was the chairman and chief executive officer of Lockheed Martin Corporation and went on to chair numerous advisory panels, including the 1990 Advisory Committee on the Future of the U.S. Space Program. And most recently, he chaired the committee that authored the profoundly important National Academy's report, Rising Above the Gathering Storm. And finally, Dr. Maria Zuber, who is currently the department head and E.A. Griswold professor of geophysics in the Department of Earth, Atmospheric, and Planetary Sciences at the Massachusetts Institute of Technology. She also served on the President's Commission on Implementation of the United States Space Exploration Policy and is a member of the National Academies of Science. Welcome to you, and then we will begin with Senator Glenn.
Thank you very much, Mr. Chairman, and members of the committee. To be asked to comment on NASA's first 50 years and then contemplate where we go from here for the next 50 years or more is a big order. It's been a wondrous half century, to say the least. Mankind, for the very first time, learned to get off the surface of the Earth and make a lot of progress in getting into this new laboratory of space. We can't help but remind ourselves of the losses along the way of good friends who are no longer with us, who were sacrificed in this whole process. But we look forward to the coming days as memorial to those folks who were good friends and who lost their lives. Exploration comes, and this will be a summary of my longer remarks, which I ask would be put in the record if we could, please. This will be a summary of them. Exploration comes down into two areas in my mind. One is macro, one is micro. Macro is going out deeper into space, going off Earth and going wherever we can learn how to travel. Micro, to me, is equally important in that it does the experimenting, the research that maximizes the research return for benefit of people right here on Earth. And that's an area that I'll give special attention to. In the first 50 years, we had the Mercury program, we had that started us off, we had the Gemini program in which we learned to rendezvous, Apollo that gave us that wondrous day I certainly will never forget when Neil Armstrong made the first footprint on someplace other than Earth. We went on that to use some old equipment, use Skylab. We built the orbiter, which could then stay up for a 14-day period of time. And along with that, we asked colleges, universities, and businesses to be involved with this because we could now do research in space that we never were able to do before. Beyond that, we developed a space station for longer-term research because we thought it was that important, and the International Space Station then when we asked 15 other nations to join us. The number of projects that were are illustrated by the fact that on STS-95, the flight of Discovery I was privileged to be on in '98, we had 83 different research projects. And Columbia, before its demise, had 90 research projects on that one flight. So the community, the colleges, universities, and businesses had reacted very favorably to our proposals to let them, or to encourage them, to use space for this new research. We have developed robotics along the way, which is amazing in its own. NASA set up they were enough into the research area that they set up a special research planning Office of Biological and Physical Research, OBPR. And they had 5 different areas under that in which they were looking forward to conducting very basic experiments: biotechnology, combustion, fluid physics, fundamental physics, and materials science. Now, there have been delays, and we look forward in those areas to longer-term research on the station. There have been delays in completing the International Space Station because of Columbia and some of the other engineering problems, but those will be eventually solved. Along the way, George H.W. Bush, our 41st president, proposed a Mars program, and there wasn't a whole lot of support for it, and when the administration changed, the idea sort of died. But another proposal for the Mars program, the vision for space exploration, was put forward by the current president, George Bush, in January of 1994. This time there was not a wait for support. The president just put a directive over to NASA to do it, and NASA responded. Congress, this was not what Congress had really voted the appropriations for that time period, and Congress responded later on to this change of direction. One note here that I would toss out to the committee is, I don't think we know yet, we don't have a clear definition of exactly what the ultimate objective of the Moon project is going to be. In Cleveland in 2007, the president said, and I quote, "And therefore we set a new mission, which is to go to the Moon and set up a launching there to further explore space." Now, I don't know that anyone has really addressed this yet, but if that's really our mission, is to set up a launch facility on the Moon, that's a whole different complicated, expensive, and questionable safety type proposal, so I think that needs to be ironed out. I favored the VSE because I assumed that it was in addition to, not in place of, existing problems, existing programs. I assumed that money requests would follow. Instead, what we got were cuts in other research to try and pay for this program, and it wound up, in my view, as the biggest unfunded mandate that we have in all government history. We had to do it. NASA had to do it. They were directed to do it, but it was out of the existing NASA budget, which is a huge job, enormous job. Congressional consent and consultation and international consultation was certainly lacking in this because there was consternation in some of those communities when this was announced. Not only would there be no increase in funding, but ongoing research at that time was cut by $1.2 billion over a 5-year period. Now, I think too often Mike Griffin, the current administrator, catches some of the blame for this because he's the one that has to implement it. I don't see that as being fair at all. I don't think it's his fault. He's as loyal a person as you could get, and if he's given a direction of doing something, he's going to do his level best to do it. He was a scientist at Johns Hopkins, headed up their space program, was formerly in the hierarchy of NASA in his earlier career, in fact, back when the first proposal to go to Mars was made. So, but he gets his direction from above, and he's a loyal soldier. He's going to do his level best to carry it out, and that's what he's been doing. But I would say this. Someone once told me a long time ago in the Marine Corps, quote, "Great plans without resources remain dreams." And nothing could be more true. Now, my colleague, the late Gus Grissom, put it in more understandable terms, perhaps, back in the days when a cut in the funding for the Project Mercury was being proposed. And Gus, being the person who could always sum things up well, They asked him for his comment on what the cuts would do, and he said, "No Bucks, no Buck Rogers." And so that did it. The shuttle has now been looked at as the source of money to continue with the program because it costs some $400 million plus per launch. And so that was looked at, and so in 2010 the present plan is to terminate that program. Then for 5 years before our own spacecraft are developed to where we can use them, for at least 5 years, it's already been extended 1 year, may go out to more, for 5 years we will be dependent on the Russians to launch our people. We will have no manned capability to go into space during that at least 5-year period. U.S. astronauts and equipment will have to be launched from and returned to Russia to have access to our station. Now, I don't think that's a very pretty picture to put before the rest of the world, quite frankly. And I've never thought I would see the day when the world's richest, most powerful, most accomplished spacefaring nation had to buy tickets from the Russians to get up to our station. I think that's a bummer. So the Soyuz is not that great at the moment either, our transportation system, because it's had its own set of problems, and this all assumes that they'll be able to work out the Soyuz problems. If they're not, we'd be left with no way to get up there, period. That would be it. Way out, well, we have $100 billion invested in this. When the station is completed, we'll have over $100 billion. Our allied nations, the other 15 nations, will have about another 12 to 15 billion. So there's a $115 billion investment that we have here, and we're not maximizing it. We could do that. We could keep the shuttles going, start restoring research in those 5 areas that NASA was looking at previously, keep the shuttle, restart research, and also keep the workforce that we have, the most experienced launch engineering team, engineering and launch personnel ever developed anywhere. So it would keep that workforce alive also. We have $100 billion investment, and if we put $2.8 to $3 billion per year additional into the program now, we could keep the shuttles, keep the research, and keep the workforce. It's a huge investment for the most unique laboratory ever put together by anybody, anywhere. And now it would cost that comparatively small amount to use it properly. A lot of money? Yes. But for this country with a $3 trillion budget, just announced yesterday, 482 deficit, well, 482 billion deficit, 10 billion a month going into Iraq. It would seem to me that we should be able to find enough money to maximize this thing, which is so important for our future. The reliability of the U.S. is at stake here also. We have scientists, the college, the university, the business, the international partners could all be brought back on stream as they originally signed on for. This fits into a bigger picture, too. We're into a time of globalization. Tom Friedman has addressed that very well in his book about the flat Earth. And Fareed Zakaria has a new book out on that subject, too. But what they all sum up to me is this. A nation that leads in the future in education for our people, which we did in the past, and which is down now. Our K-12 education is not in good shape now compared to other nations. But our education and research, the second element is research. We learned the new things first. And with an educated citizenry, put them together. And NASA is a good example of that, and NACA, its predecessor, that gave us the basis for the aircraft industry as we know it today. Our spacecraft, our space program, is admired as a symbol of a great nation, willing to propose great projects and carry them out for the benefit of all mankind, and a true world leader defining what the future will be and in turn making it happen. NASA had a mantra at one time that said their goals were to improve life here, to extend life to there, to find life beyond. If we follow that prioritization, and I think we can do that and still do the VSE, if we have the will, but I would caution once again, a great plan without resources remains a dream. Thank you, Mr. Chairman.
Thank you, Senator. You know, NASA, as well as this committee, was created by that so-called Sputnik moment. And I think that there's going to need another Sputnik moment before we're going to have those resources you speak about. I just hope that it is not when we have to, as you say, buy a ticket from the Russians to go to the space station or follow the Chinese back to the moon, because once you have to, there's a lead time. Once you have to start catching up, you become years behind. So thank you for your good advice. And now we'll hear from Norm Augustine.
Well, thank you, Mr. Chairman and members of the committee. It is a distinct honor to appear before you today at this hearing that recognizes the 50th anniversary of NASA, as well as of this committee itself. And it's particularly to do so in the presence of these colleagues. I had the good fortune to be in the control room when Senator Glenn took his most recent flight, and that was a great occasion even to sit on the ground and watch. I probably should note at the outset that I'm here today as a private citizen, and I'm not representing any of the organizations that I've been associated with along the way. Some 50 years ago, as a graduate student in aeronautical engineering, I was passing under the tower at Princeton's Graduate College, and another student came running up to me and excitedly said that the Soviets had just launched a Sputnik. And frankly, my first words were, "What's a Sputnik?" I was soon to learn, and I recall feeling almost as if a body blow had been delivered to me. This was in the midst of the Cold War. America was supposed to be preeminent in science and technology, and the Russians had beaten us into space, and that was unfathomable. And it, of course, carried enormous repercussions, economically, particularly militarily, as well as in the space arena itself. That was a period when America's leadership in science and technology was, to a very large degree, taken for granted. It had been little noted that the underpinnings of that leadership had been gradually eroding. Our investment in science and technology was not commensurate with the leadership position that we thought we had held. Our public schools were showing signs of neglect and deterioration, particularly when it came to the teaching of mathematics and science, and our production of scientists and engineers was stagnating. As it turned out, as you have noted, the Soviets inadvertently did us a very great favor. America was awakened, and America stayed awakened throughout the rest of the Cold War. NASA was formed not only to assure leadership in aeronautics, but now in space as well. This very committee, as you've noted, was formed to assure that the health of our nation's science and engineering enterprise was subjected to continuing attention by the Congress. The Advanced Research Projects Agency was formed in the Department of Defense. Our public schools took steps to improve the quality of the education that our children were receiving, particularly in the areas of science and technology. And more young people were attracted to the fields of science and engineering as we set new goals, and in particular the Apollo program. Well, Mr. Chairman and members of the committee, fast forward, if you will, 50 years to an era of globalization, as mentioned by Senator Glenn, an era driven in no small part by advancements in science and technology. And Americans, by and large, are very confident of our leadership in these fields. After all, who discovered the laser, the transistor, and the integrated circuit? Who sequenced the human genome? And who invented the personal computer and the internet and the GPS and the iPod and so on? NASA's former administrator, rather revealingly, tells a story of, and I'm referring to Dan Golden, tells a story of being criticized by a citizen who thought that NASA was investing too much in Earth satellites. And the critic had asked, and I quote, "Why do we need meteorological satellites? We have the Weather Channel." Little notice today is that there were almost twice as many bachelor's degrees granted in physics in the U.S. the year before Sputnik as there were last year. Little noticed is that the number of engineers graduating with bachelor's degrees declined by over 20% in a recent two-decade period, with a modest uptick the last 2 years, due in no small part to foreign students studying in this country. Or that the number of PhDs in engineering declined by 34%. The PhDs granted to U.S. citizens declined by 34% in a little over a decade, again with a slight uptick due principally to foreign students increasing. Or that our public schools constantly rank near the bottom of the class when it comes to international tests, particularly in math and science. We're surpassed by such nations as Azerbaijan and Latvia and Macau. This time there's no Soviet Union to give us a precipitous wake-up call. China may do us the favor. More likely this time we'll have to awaken ourselves. Once awakened, as we all know, Americans can do some truly remarkable things. Not long after NASA was formed, Senator Glenn, of course, greatly strengthened our national pride. At a time our nation badly needed encouragement, Neil Armstrong and Buzz Aldrin, aided by Mike Collins, gave us the ultimate lift. And soon, 10 more of my friends walked on the moon, and all of them returned safely. As Buzz Aldrin has said, it's amazing what one person and 100,000 of their friends can accomplish. NASA's original charter, it's worth noting, emphasized the positive impact that space activity can have on education. And in my own experience, there's nothing that excites children more than space and dinosaurs, and we're short on the latter. As a person who witnessed these past 50 years and was a member of the committee that was established by the White House and NASA to look at the future of the U.S. space program, created not long after the Challenger accident, I think I've learned a lot of lessons along the way. And what I would like to do in the interest of time, Mr. Chairman, if you and the committee would permit me to submit the full statement for the record, I've listed quite a number of those lessons that I think are important and that have a bearing on future space activities of our country. I just conclude by observing that I think America could take enormous pride in what NASA's accomplished these past 50 years, all of which, to our nation and NASA's great credit, has been accomplished in the glare of the public spotlight. NASA, like any other organization that involves human beings, is not perfect. But if NASA sets perfection as a goal, I believe we have a great deal to look forward to in the next 50 years. Thank you.
Thank you, Mr. Augustine. Now, Dr. Zuber, we'd love to hear from you.
Thank you. Mr. Chairman and members of the committee, thank you for the opportunity to appear today at this notable event celebrating the 50th anniversary of NASA. Exploration and discovery are human imperatives. Our efforts to investigate and understand the unknown found the foundation upon which our nation was built. NASA exemplifies the pioneering and innovative spirit that built our country into the world leader that it is today. We all know the story of the Apollo program and our nation's successful quest to send humans to the moon. In parallel, NASA's robotic space program got off to the same quick start. Progress continues today. Both these endeavors contributed to NASA's science program. It was only 2 years from the launch of the first U.S. satellite, Explorer 1, in 1958, to the launch of the world's first weather satellite, TIROS-1, and 2 more years to the launch of the first planetary mission, Mariner 2, which successfully flew by Venus. My written testimony, which I submit for the record, details the extraordinary achievements made by NASA in revealing the nature and workings of the Earth and the solar system and other planetary systems. These discoveries relate to the formation of our solar system, the violent bombardment of ancient planetary surfaces, the origin of the moon, the thick greenhouse atmosphere of Venus, water on Mars, winds on the giant planets, an ocean beneath the surface of Europa, hydrocarbon lakes on Titan, the discovery of an icy world larger than Pluto, and Voyager 1's trek to the edge of our solar system. And while we rightly consider NASA to be the space agency, its history of discovery in Earth science is, ironically, out of this world. NASA can claim credit for the Van Allen radiation belts, mapping the ocean circulation, biological ocean productivity, global wind patterns, the structure of hurricanes, and direct measurement of the drift of the Earth's tectonic plates, water movement in subsurface reservoirs, and changes in atmospheric ozone that led to the discovery of the ozone hole. But what's next? Because one doesn't know where the next significant discovery will arise, a balanced scientific program is essential. Opportunities need to be selected on the basis of strategic plans that are formed by community input that identify the most compelling science within the context of tractable implementation. The moon is a fascinating target for future study. Apollo produced a treasure trove of information in the lunar samples that are still being analyzed today, but they sampled only a half dozen locations. Many more scientifically areas exist, such as within dark polar craters that might contain water ice. As the most accessible planetary body, future study of the moon will provide transformative advances in understanding the evolution of all terrestrial planets. Returning samples from Mars from sedimentary and ice-rich environments with well-studied geological context should be the highest priority in future Mars exploration. Such samples will match the value of the moon rocks in deciphering that planet's early and present environment. The outer solar system offers numerous thrilling destinations for future study. For example, several of the icy moons may have accessible liquid water and organic materials, and they hold the possibility for harboring life. Future study of asteroids and comets is of both scientific and practical interest. A detailed study of the internal constitution of a near-Earth asteroid would illuminate the challenges that would be faced regarding hazard avoidance in the event that such a body is one day discovered to be on a trajectory to impact the Earth. There seems to be a spectrum of opinion both within and outside the agency as to how much NASA should be involved in Earth science. As head of a preeminent Earth science department, I have a strong opinion on this topic. The Earth is a complex dynamic system that requires detailed in situ study and precise global views repeated over time to unravel its workings. No other agency is capable of developing the kind of state-of-the-art sensors and observation techniques that NASA can provide. NASA simply must play a role in the essential mission of understanding the Earth. Science goals of high merit in all fields of Earth science have been prioritized in a recent decadal study in which I participated along with many members of the scientific community. Programs to study solar and Earth radiation, changes in the heights of ice caps, land and ice surface deformation are justifiably recommended with high near-term priority as they relate to climate change. One of the most remarkable discoveries in space science over the past couple of decades has been the detection of planets around other stars, known as extrasolar planets. After years of unsuccessful searching, over 300 of these objects are now known, and their rate of discovery is rapid. The great challenge in the coming decades is to image Earth-sized planets in the so-called habitable zone of their stars, where conditions favor Earth-like life. Judicious investment in new technology will be required to take future giant steps. Technological hurdles tackled early in advance of mission selection are the best prevention against cost overruns. There is much worthwhile science to be done, and NASA can't afford to do it all. Prioritization based on community input and available resources will allow us to move productively forward. A stable funding profile in space and Earth sciences is essential to progress. Here I acknowledge and in fact applaud the efforts of the committee and their strong support of NASA science, exemplified by the most recent NASA bill passed by the House. The role of the space program in inspiring young people to pursue scientific and technical careers is often noted, but evidence is anecdotal and difficult to quantify. We don't know how many people inspired by the space program pursued a math, science, or technology degree who wouldn't have done so anyway. But much anecdotal evidence exists to suggest that the numbers are huge. Many of those inspired grew up to pursue technical careers in things such as computer science, the telecom industry. They're engineers, physicists, even biologists. Young people now fascinated with the latest discovery from Saturn or in driving Mars rovers have the potential to take on the greatest societal changes in energy, the environment, and healthcare. Students inspired to pursue scientific careers must then be trained. In my own university, students interested in energy flocked to me and other NASA-funded researchers to obtain experience in remote sensing, chemical analysis, robotics, and instrument design. Stable funding base to universities, all awarded via peer review, is crucial for training scientific and technical professionals in the future. Maintaining the best technical and scientific workforce will require access to the entire pool of top talent. We must work tirelessly to attract and engage all students with mathematical and scientific aptitude, independent of gender, race, etc. We must provide opportunities to top scholars from the international community to participate in American Earth and space science endeavors, recognizing their potential for contributing to our technical preeminence. In summary, NASA is the federal agency where dreams reside. Its can-do attitude and propensity for taking on tasks, in President Kennedy's words, because they are hard, exemplifies so much of what is great about our country. Other nations emulate us, follow our lead, and partner with us in peaceful exploration of the solar system beyond. But I should say, in closing, almost every spacefaring nation on Earth currently is exploring or has plans to explore the moon, and the rest of the solar system can't be far behind. Will people really view the United States as the greatest nation on Earth? Chinese astronauts are walking on the moon when we're not. Genuinely appreciate the forum that the committee has provided to recognize the achievements of NASA, and I look forward to responding to your questions.
Thank you very much, Dr. Zuber. Before we begin with questions of our witnesses, as I noted earlier, the noted physicist and author Dr. Stephen Hawking has graciously provided a pre-recorded message for today's hearing, and we would like to hear that message now.
Chairman and members of the House Committee, thank you for the invitation to address you today. I regret that I cannot be here in person, but I hope that this recorded testimony will be of interest and use for you at this hearing. This is the 50th anniversary of NASA. It has achieved major advances in science, as well as great improvements in technology. I want to celebrate that, and to argue for the continuation and extension of the space program. Why should we go into space? What is the justification for spending all that effort and money on getting a few lumps of moon rock? Aren't there better causes here, on Earth? In a way, the situation is like that in Europe before 1492. People might well have argued that it was a waste of money to send Columbus on a wild goose chase. Yet the discovery of the New World made a profound difference to the old. Just think, we wouldn't have KFC or the Big Mac. Space exploration will have an even greater effect on us. It could completely change the future of the human race, and could determine whether we have a future at all. It may not solve all of our immediate problems on planet Earth, but it will give us a new perspective on them, as well as giving us more information on some of the challenges we face, such as climate change. Going into space is not cheap, but it takes only a small proportion of world resources. NASA's budget has remained roughly constant in real terms since the time of the Apollo landings, but it has decreased from 4% of the federal budget in 1970 to 0.6% now. Even if we were to increase the international budget 20 times, to make a serious effort to go into space, it would be only a small fraction of world GDP. Still, there will be those who argue that it would be better to solve the problems of this planet, like climate change and pollution, rather than heading out across the cosmos in search of a new world. In my view, we need to do both. The space program has an important role to play in protecting the planet on which we live. It allows us to look back at the Earth from space, providing vital information to world leaders about climate change and cross-border environmental problems, such as shrinking polar ice caps, deforestation, and desertification. NASA has about 50 active space missions in orbit at the moment, looking both inward and outward. They supply us with information, not just about other worlds out there in the solar system. They also show us the impact mankind is having on the delicate ecosystem of the Earth. So we can go out and explore space, but we can also look back from space and learn more about our own planet and how to protect it. This will have a great impact on our future, both on this planet and out in space. Isn't our future worth a fraction of a percent? We thought space was worth a big effort in the 60s. In 1961, President Kennedy committed the U.S. to landing a man on the moon by the end of the decade, which was achieved with Apollo 11 in 1969. The space race helped to create a fascination with science and led to great advances in technology, including the first large-scale integrated circuits, which are the basis of all modern computers. However, after the last moon landing in 1972, with no future plans for further manned spaceflight, public interest in space declined. This went along with a general disenchantment with science in the West, because although it had brought great benefits, it had not solved the social problems that increasingly occupied public attention. A new manned spaceflight program would do a lot to restore public enthusiasm for space and for science generally. Robotic spaceflight is currently preparing the way for human exploration of other planets in the solar system. The Phoenix Mars lander, which successfully touched down on Mars on 25 May of this year, has already provided visual evidence of water on Mars. Soon, we hope it will send us chemical evidence of the presence of water. From Earth, we know that where there is water, however hot or cold the temperature, there is life. Finding water on Mars would also mean that a future Mars colony could use it as a source of oxygen. It is the first step to spreading the human race out into space, which I'm arguing has to be our long-term aim. A goal of a base on the Moon by 2020, and of a manned landing on Mars by 2030, the two most suitable sites for space colonies in the solar system, would reignite the space program and give it a sense of purpose. A new interest in space would also increase the public standing of science generally, in the same way that President Kennedy's moon target did in the 1960s. The low esteem in which science and scientists are held is having serious consequences. We live in a society that is increasingly governed by science and technology, yet fewer and fewer young people want to go into science. This matters greatly to all our futures. The children of today are the adults of tomorrow, and they will need an understanding of science if they are to make the decisions which will affect us all. It is vital that we inspire them to take an interest in science. At present, we cannot travel very far across our solar neighborhood, but we are gaining knowledge about what lies beyond, thanks to space telescopes such as Hubble, and the recently launched Gamma Ray Large Area Space Telescope. This telescope will allow us to explore the high-energy world of phenomena which emit gamma-ray radiation, and will help us to answer questions such as how black holes can accelerate jets of gas outward at incredible speeds. Physicists will be able to study subatomic particles at energies far greater than those seen in ground-based particle accelerators. And cosmologists will gain valuable information about the birth and early evolution of the universe. There are other important scientific missions, but it would be too much to list them all. What about finding new planets beyond the solar system? Our observations indicate that a reasonable fraction of stars have planets round them. So far, we can detect only giant planets, like Jupiter and Saturn, but it is reasonable to assume that they will be accompanied by smaller, Earth-like planets. Some of these will lie in the Goldilocks zone, where the distance from the star is in the right range for liquid water to exist on their surface. There are maybe 1,000 stars within 20 light years of Earth. If 1% of these have an Earth-sized planet in the Goldilocks zone, we have 10 candidate new worlds. We can't envisage visiting them with current technology, but we should make interstellar travel a long-term aim. By long-term, I mean over the next 200 to 500 years. The human race has existed as a separate species for about 2 million years. Civilization began about 10,000 years ago, and the rate of development has been steadily increasing. We have now reached the stage when we can boldly go where no one has been before. Thank you for listening.
I hope Dr. Hawkins is one of the 2 million plus watching this on webcast today, and if so, we want to thank him for his testimony, and more importantly, for his great contribution to the universal body of knowledge. At this point, we will now open our first round of questions, and the chair recognizes himself for 5 minutes, but I want to try to be brief because we have a lot of members here, and I want to get on to their questions. But I would like to ask one question, just one question of the committee at large, following up on Dr. Zuber. As she talked about the potential for, not the potential, but the asset that NASA has in being able to inspire, particularly inspire our youth. What do we need to encourage NASA to do to be more effective using that inspiration to try to get young folks into the STEM education programs, and then hopefully after that into careers in science technology? So Dr. Zuber, we'll start with you and welcome anything that Senator Glenn or Mr. Augustine might have to say.
Okay, well, I would like to press for the ability to pursue creative programs. Some of our most inspirational things, as I related to in my testimony, don't have metrics of success. Okay, and my testimony, I mentioned how people who watch bins of Saturn swirling, who watch Mars rovers, we don't know how many of those people are going into science. in NASA education programs, there tends to be an emphasis on doing things where you can measure what the success is. And some of those things are excellent, and keep doing them, but we should also encourage creative programs where you can't necessarily measure the success, but you know that the success is there.
Well, I'd just like to back up on what Dr. Zuber is talking about here. I think that the nation that leads in education for all their people and in basic research, those two very fundamental things that built this country, whoever leads in that is going to lead the world in the future. We still lead in those areas except K-12. Our K-12 education system is not in good shape now, as we all know. But I think we should be trying to set up the best education system possible and the best research we can. And that's the reason that I think we should be doing the maximum research we can on all the, with NASA's efforts. Their funding in that area as far as research goes has been cut. I ran into a statement on the out of U.S. Aviation Week and Space Technology of a year ago, July 20th or 30th issue, in which they said, according to a National Academy's Space Science Board tabulation, NASA pulled the funding plug on 59% of its human research program investigators, the ones who would have dealt with basic long-term research concerns, as well as 88% of fundamental space biology investigators, along with 84% of its physical science investigators. They go on to discuss why this was, but it's because we did not provide the money to follow the President's VSE, Vision for Space Exploration. We cannibalized within NASA itself out of other programs to provide the money to do that. And that's what I have proposed correcting. So,
Mr. Augustine.
I would just add that it's been my observation that if one wants to inspire young people, one has to have accomplishments that they can see and relate to and or become excited about. But that's only half, I think, what is needed. The other is to have clear, longer-term programs and goals that they believe in, that they think that they might be able to become involved in as they get older. And certainly when I was young, the Cold War, that was, if you were a scientist or an engineer, you wanted to help win the Cold War. Then the space program drew that kind of excitement, and it was the information revolution. Now it's the biosciences, I think. And not only do you have to have immediate accomplishments, but one has to have goals in the future that young people can really believe in and embrace.
Thank you, all of our panel members. And then, Mr. Hall, you're recognized for 5 minutes.
Mr. Chairman, I thank you. Senator Glenn, I'm very interested in your comments about the fact that shuttle launches are expensive, and then you go on to say the ISS is scheduled to be completed during 2009, and to save money, shuttle use will be terminated in 2010, leaving us at least a 5-year period in which the U.S. will not have a human space launch capability. That concerns me, and it seems to concern you. I know money's, ask us the value of money, and somebody said, well, it's not much, but it sure keeps you in touch with your kids. Well, I think money is a matter here that we need to discuss, and we need to think of somewhere that we're expending money or doing something that's way less important than it is to have the leadership in space exploration. Yes. I'd like for you to go a little further on that. I'd even like to suggest that we cancel any foreign aid to those that vote against us 90% of the time in the UN or things like that. That's never worked before. Maybe we ought to look at that again. But I'd like your idea on some of the things we could do without, or how we could lessen it, or how we could provide that thing called money that NASA has to have to make those, and not rely on Russia or some fallibility in our own ability to get from here to Russia or from here to the moon or to Mars or wherever we're trying to go.
Thank you, Mr. Hall. Appreciate that. That's the direction we're going right now. We will be dependent on the Russians for launch. Our people will go over there for their launch, and any equipment we have will have to go up. It will not be a heavy launch capability because they can't put up the same loads that we can on the shuttle. But I just thought I'd never see, as I said earlier, I thought I'd never see the day when we'd be buying a ticket on the Russian system to get our people to our International Space Station, yet that's what we're doing right now. I think we've already signed contracts, as a matter of, as I understand, some $700 and some million for launch services from the Russians already. But I just think that's a wrong way to go for the world's greatest spacefaring nation.
And you say that additional funding of $2.8 to $3 billion per year could keep the shuttle in operation until our new Constellation program equipment is ready and at least partially restore the ISS research program.
That's what I've been told, Mr. Chairman, and you'd want to flesh that out with NASA, I'm sure, and get the details of exact amount. But those are approximate amounts, and that would keep us with our own launch capability, as I understand it.
I'm not only concerned, but I'm really astounded that we're going to go 4 years without the ability to visit our own station.
Five years now. We had a 1 year slippage, and there may be more. Maybe more slippage beyond that, of course, that 5 year estimate is dependent on our new equipment working out perfectly and being available at a certain time. If we have any delays in it, then our dependence on the Russians will go even further.
I think that's one of the major problems we have in the program. Yeah. Thank you, John.
Mr. Miller is recognized from North Carolina for 5 minutes. All right. Ms. Giffords is next up. Sure. All right. Ms. Edwards, our newest member of the committee, is recognized for 5 minutes.
Thank you, Mr. Chairman, and thank you to our witnesses. I listen with fascination about the space program. I had the great privilege of working for Lockheed, actually out at Goddard Space Flight Center, supporting Space Lab and TDRS and Landsat, and the early days of the development of the Space Telescope. And I had the benefit also of learning from engineers and scientists who started out with NASA in 1958, who were my mentors. And one of the concerns I have is about the sort of resident experience within NASA at the highest levels of, our scientists and people who understand technology, both for their oversight role, but also for the value they play in the long-term sustainability of NASA and its resident knowledge. And so I wonder about your comments about that. And then because I'm out in a community that supports the Goddard Space Flight Center, what I've noticed is that so many people actually don't even know that that's a jewel in our community. It hasn't been exploited in nearly the way that it can, both as an engine for economic development, but also for the value to our schools and our young people. And so I'm curious as to whether any of you have comments about what we can do to really tell the story of NASA and the space program and exploration and the real valuable, tangible value to our communities, and ways that we can inspire our young people to get to reap the benefits of that technology.
I'll address that. I used to be a Goddard civil servant. First of all, with respect to the NASA civil servant workforce, I feel your pain. It seems like there's always a hiring freeze at NASA, and it's very difficult to hire. There are freezes on hiring, and a lot of expertise is brought in from general areas just for short periods of time to do small jobs, when there are engineers and scientists who would love to have these jobs. They are not the highest paying jobs that can be had, but people would love to have them. I'm actually on an advisory committee to the science director at Goddard in dealing with improving the role and maximizing the contribution of women at Goddard. And one thing that you find is that people would love to have that job because of the quality of life that's associated, and the the prestige that's associated with working for the space program, and that salary and compensation, people need a good wage to make a living, but beyond that, people are much more excited about a situation where they can contribute to the space program and deal with their family responsibilities. So first of all, making flexibility for family situations is one thing that would be more attractive, but anything that the government could do to make hiring more civil servants there a possibility would be great, and this is a place where maybe the committee could help.
Ms. Edwards, you raised two, I think, very important points. Pardon me. I share the concern about the aging of the workforce and the talent in the space program. And I think the biggest problem that our industry, the industry element of the space program, is likely to face in the decades ahead will be a shortage of engineering and science talent. And it's also been my observation that the space program, it's a risky business. And it's a lot like performing heart transplants. You should either do a lot of it or none of it. And I've noticed that when we start phasing down people, we start having trouble because we have inexperienced people. So I think you raise an important point. The only thing I would add to your second point would be that I believe our corporations and our universities and our national labs could do an awful lot more in terms of working with young people and getting them involved in what they're doing, giving them summer jobs. There are other organizations I'm sure you're familiar with, like the Challenger Center, that does a lot, and these entities are there waiting for people to support them.
The lady's time has expired. As you know, Mr. Augustine, part of the Competes bill was to use our national labs more, to bring those teachers and students in, and we're starting to see them implement some of that. Now we have the former chair of the the Space and Aeronautics Subcommittee, Mr. Rohrabacher, is recognized for 5 minutes.
Thank you very much, Mr. Chairman. It's been my honor to be on this committee for 20 years, and I elected this committee the first year. And let me just note, George Brown was the chairman at that time, and he remember the leadership that we had over the years, and George Brown and Walker with us, and Short as well today. And let me just add, Mr. Chairman, that I believe that you are conducting leadership respect and admire of you. To set the record straight, I believe that Senator Glenn was not a naval aviator, but a marine aviator, if I am.
Well, they're both.
Right, and my father actually served with Senator Glenn when he was in the something he talked about a lot and was very proud of. Let me get to certain questions here, because I do want to ask some questions. Dr. Zuber, I was very appreciative of your statement today, because you mentioned, not only did you mention asteroids and comets, but you also mentioned the word prioritization. Areas have a special interest for me. First of all, let me ask you, and I'm going to ask the panel just very quickly, can you please name one area that you would cut, that we could make a few $billion in cutting, so that we can actually accomplish the mission that I think Senator Glenn has told us is an important priority for us to accomplish, which is making sure we have that capability for launch capability. Is there an area that we can cut and we can focus the money on that?
I'd be in big trouble if I. What I would say is new starts. That you can't start new things unless you finish what you're doing.
Okay,
and I think
fair.
NASA has run into some
new
troubles
starts
in
would
this
be
area.
made perhaps exploration new starts, and where you're saying go explore this particular moon of Jupiter or whatever, and we shouldn't start that till we get something else done.
Well, we should be far enough along that we know that we can pay for things before we start new things.
Dr. Augustine, do you?
I would certainly agree with that we should be measured by what we finish and not what we start, and new starts are a candidate. The other is that the really large consumer of funds is indeed the shuttle, and sooner or later the shuttle has to be replaced. And the commission that Chairman Gordon mentioned that I was involved in 18 years ago now made as one of its highest recommendations to build a replacement for the shuttle. And we had forecast in our report that we'd likely lose one or two more shuttles before we were done. And unfortunately, we've been on that path. So I think we have got to get a replacement to get us into space without using the shuttle.
Right. Senator Glenn, do you have one area would you like to actually say is less important than another area?
I have no particular one. It just seems to me when we have a $3 trillion budget, that's 3,000 millions or whatever it figures out to be. I just think this, or billions, that we can find 2.8 or 3 of them in there someplace that are better spent on maximizing this research return on a $100 billion investment we have made. We're not doing that now. We have empty racks going up into space or planned now because we don't have the support for filling them.
Actually, I've got some ideas of where we could cut the budget myself, but no one ever listens to me. So, but let me ask one other question about prioritization. There's a prioritization on the other side, and this is where Dr. Zuber's comments on asteroids and comets come into play. I happen to believe, and I've been pushing this, and as you all know, that the idea that planetary defense is something that NASA should be focusing on because there could be a comet or an asteroid or a meteor that could hit. No one would be surprised if one of those was identified tomorrow as a potential threat to millions of people's lives on this planet. Do you believe that planetary defense should be a priority mission for NASA? And just quickly down the line.
Well, I think that defense, the role of defense is in the Defense Department, but I do think that there are things that we can do in the study of comets and asteroids that are scientifically important, but that would contribute significantly to the question about how to take action, if action were ever needed to be taken.
And the action should take place at the Department of Defense, is that?
Well, the actual defense part should be done by defense, but
Dr. Augustine?
If history is any precedent, this will be a problem at some point. Chances are it's in the distant future. So I think it's something NASA should be concerned with, but I don't think it gets the highest priority of what they might do.
Well, I don't know that I would assign that to the Defense Department. They have their plate full right now. It would seem to me that the Defense Department normally deals with earthbound threats to our country and our security. This is a little bigger than that. I would think that, and the question also arises, let's say we do find a trajectory that's coming toward Earth, what do we do about it? It's going to be very interesting, but you're probably going to increase church attendance considerably. But that's going to be about it for a while, it would seem to me, unless we have some means of defense. And I know people have proposed that in something like this we might be able to actually go out into space, implant or take with us nuclear or powerful weapons of some kind that would be able to alter the course or destroy that asteroid on the way in, or comet, whatever, or asteroid on the way in. But I think it would be, I'd like to know that something like that is headed toward Earth, certainly, and we can make observations of that.
Thank you very much. And let me just note that in the next 50 years, if we do indeed see an object headed toward the Earth that could cause millions of deaths, people, and maybe even extinction of the planet, that maybe the most important thing that NASA will ever do will be to determine that object and to be able to help deflect it from its course. Thank you very much, Mr. Chairman.
Gentleman's time expired. The gentlelady from Arizona, Ms. Guilford, is recognized.
Thank you, Mr. Chairman. While I was basking in the brilliance of our panelists, I got called out, and I beg your forgiveness, to attend a meeting on homelessness from the state of Arizona. And it's sort of a reality check I was thinking about how great it is being on this committee and how wonderful to have these panelists, and then you have to step out to meeting and talk to folks who represent your community of people that don't have enough food to eat and don't have shelter. So it's a real challenge. I mean, I think about Dr. Hawkins, who I had a chance to meet. You, sir, last year when you were presented the medal that was flown on STS-123 over at the Royal Society, which was amazing. Senator Glenn, you are an inspiration to all of us in the private and the public sector, and Mr. Augustine, for everything you've done with your work with the national academies, of course, and in the private sector. And Dr. Zuber, thank you. We love having particularly women in science. As a woman in a non-traditional field as well, it's really important that we have everyone represented. So I guess my question is, and I just want to cut straight down to it, how are we going to do this? I, over the weekend, had a chance to present a state of the economy to a lot of people in my district, talked about where we were in terms of debt and deficit, and I also wove in there a lot about math scores in Arizona and the country, 4th grade math scores, 8th grade math scores, 12th grade. I mean, we as a nation have to get going right now. And for the smartest people on this committee and our panelists, how are we going to do that? How are we going to say to the next generation, we are going to keep the standard of life, the beauty, the vision of this country headed in the right direction? And so I know we don't have a lot of time. You only have 5 minutes to ask us questions, but I turned it over to our panelists to tell us how we're going to make this happen.
Let me begin. Great question. I guess I'd begin by observing that 96% of the workforce in this country are not scientists and engineers. But that 4% that are the ones who create the jobs disproportionately that help solve homeless problems and provide the money. And so I think what is your question, what is it we should do? I'll offer 2 highest priority. One is we ought to greatly increase the science budget in this country so that we have new discoveries, that we create new products and create jobs for people. The second is that we need to get teachers in our classrooms all the way down to 1st grade who understand math and science and who have a primary degree in that core field so that they can answer the questions that children ask, so they can inspire them, so that they can tell them why what they're doing is relevant. I think those are the 2 highest priority things that we should do. Thanks for a great question.
Okay, well, NASA itself can't solve all of the education problems in the country, but they can certainly contribute. The decision kids have to make, and I think it comes when they're between elementary school and middle school, is do they keep taking the harder math courses or do they go the easier route? And they need to see something out there that gives them the feeling that putting in the extra effort to take the harder math course or the harder science course is worth their while. So in that sense, keeping discovery in space science, earth science, and in fact all science, I think is key in that endeavor. And I just want to echo Mr. Augustine's comment that having teachers in science and math who are actually science and math majors and who understand those disciplines deeply and who have opportunities for career enhancement in summer programs, that is, one of the best investments that this country could make.
It's a very good question, and it always comes up about whether we should solve the problems that exist now before we put money into research where we don't know for sure what the answer will be. Is that wasteful? And that's basically the questions you asked, I think. It seems to me that our research in this country, if there's one thing we've learned throughout our history, it's that money spent on research has a way of paying off in the future, usually beyond anything we see at the outset. And not every aspect of that research is productive, but enough of it's productive that that's how we moved ahead. What we're saying by research is curiosity. And every single advance that humans have ever made has been because somebody was curious about could we do things new way and do them differently, and whether it's a microphone or whatever it is, can't we improve on this? And somebody had that kind of curiosity and looking into the unknown. An example, you mentioned the problems of the homeless. Very concerned about that too, back home in my home state of Ohio. But we An example of this might be in feeding the homeless even. Look what's happened in agriculture. In the early days of this country, we had 95 or 96% of our people involved in agriculture to support the population. We're down now to about 2.8% of our people give surpluses that are enormous, so much so that we pay people not to produce. And that was because of research on hybrids and on soil and on fertilizer, seeds, just across the whole panoply of about 8 or 9 different things that go into that consideration in agriculture. And people thought maybe at that time it was goofy. Why did we have to do that kind of stuff? We're looking into fertilizers, for heaven's sakes, on the farm. It's always been okay, but yet we improved them enough that we have more increased production, and that does benefit the homeless now. So it seems to me taking a long-term view of what may come out of research is the way we should go.
The lady's time has expired, and let me just point out, Ms. Gifford, in response to your question, I think there was concurrence that we need to be able to help educate our educators in terms of their core knowledge in the math and science areas, as well as make an increased investment within our science research. Well, this committee and Congress has passed that legislation. The President signed it last year. We have that authorization in the Competes bill now. We need to fund it. We've got the roadmap. And the gentleman from Washington State, Dr. Baird, is recognized for 5 minutes.
Thank you, Chairman. What a treat to be here with such distinguished individuals. Thank you for your service here today and for your many years of service to the country. I am in a bit of a conundrum in that I share with great passion the belief articulated by Dr. Hawking, by the panelists today, that part of our destiny is to explore, and that I think part of our human destiny is to leave our solar system. We have to do it. Our curiosity drives us there, but our desire to preserve the species does as well. So I believe that. I've followed the space program avidly since I was just a little child. But my concern is I'm also on the budget committee, and we're approaching a $500 billion deficit. We've got a $9.4 trillion debt. Our present value of our long-term commitments exceeds $52 trillion over the next 75 years. And I look at pictures of the Mars mission, and, here are sort of geodesic domes with astronauts walking about, et cetera, et cetera. And, those of us who watched the Star Wars movie, I sometimes wonder who the heck built those things. You watch the Star Wars, there's these giant artificial planets that people live in. Somebody's got to be out there building this stuff. And where do they build it, and how do they fund it? So my real question is this. We can make or revise laws, but we can't revise the laws of physics. And this notion that we're going to just put these big manufacturing plants on Mars somehow assumes that we've got the launch capacity to move a lot of junk a long ways at enormous expense. And who's going to say, Mr. President, that's a dandy vision, but here's what it's really going to cost? And can you talk to us a little bit about what it would actually cost this country? I think maybe we should do it, but we're not prepared at all to make the sacrifices that it would require to do that. So can you talk to us a little about the realistic cost of putting these kind of stations up on Mars or wherever else to make this a reality?
Nobody wants it.
Okay, let me start. So first of all, nobody knows the cost. Okay, nobody. We looked at when I was on the Presidential Commission, and we looked at the cost of returning to the moon and going to Mars. We used the analogy of the cost to cure cancer. Okay, nobody. When we decided in this country that we needed to attack cancer, nobody knew what it was going to cost. They only knew that it was worth doing.
When we decided to attack Iraq, nobody knew the cost, and they told us it'd be less than $100 billion. I'm very, with respect, concerned about that beginning point for an argument. I've seen the movie.
Okay, so we don't know what it costs. Okay, but what I can say is that in the robotic program to study Mars, we have learned an amazing amount about Mars in the past decade, which is providing the enlightenment needed to move ahead towards trying to understand what the cost would be. And let me give you 2 examples. First of all, we've understood the structure of the atmosphere and the variability of the atmosphere, which is going to come into the issue of how do you land on Mars. The second thing that we've learned is that sensors both on the surface and in orbit have detected vast amounts of frozen water in amounts that are so great that it can't be tied up in the mineral structures of rocks. And that means that water ice in frozen form exists in great amounts within a meter of the surface of Mars, and we know where. So the most expensive thing you're going to take with you if you go to Mars is water. Okay? Now we know there's water there, so you don't have to take your own. So that discovery in itself has decreased the amount of launch capacity that's going to be needed to go for humans to go and stay. Okay? Now these are two small examples, and there are 1,000 other things that we currently don't know that we would need to know before we send humans to Mars. But I think that within the last decade of exploration of Mars, those questions are being addressed, and the technical questions are being addressed, and it's going to take a lot more study to try to figure out what it's going to take.
But the question is our objective to go to Mars? If that's our ultimate objective on this, and it seems to me the moon is questionable as a way station. The president made a statement, as I read into the record earlier, when he was in Cleveland about a year ago, that we'd go to the moon and launch from the moon to Mars. Now, if that's what we're doing, which I don't believe it is, but if that's what we're thinking about doing, that's enormously expensive. We're talking about taking thousands of tons of equipment, literally, with all the energy required to lift it off Earth, put it into Earth orbit, accelerate it on, go up and fall across this equigravisphere point where it then falls toward the moon, and then carry enough energy along to actually set it down to zero it out again on the moon's surface, and then start all over again on a launch, granted with 1/6 the gravity of Earth, but launch from there to Mars and check out spacecraft and do all the things that Cape Canaveral does right now, and do it in a vacuum on the surface of the moon. That's an enormous order if that's the direction that we're going. Or are we going to go into Earth orbit, build up our vehicle to where we have it built up to go to Mars, could be a good sized vehicle as far as that goes, and then accelerate it out of Earth orbit. It would seem to me that would be the cheapest way to go. But NASA has done studies on all of these things, and you could get definite information from them on that. For me to stay in Earth orbit, or for anything to stay in Earth orbit, you're going about 4.8 miles per second, almost 5 miles per second. I believe I'm correct that Neil, when he went to the moon, had to get up for escape velocity was around 7 miles per second, then falls up there, slows down, goes across that equigravisphere point, falls toward the moon. To go directly from out of that Earth orbit to Mars, as I understand it, is about 7.4 miles per second. So you have most of your energy expended in Earth orbit here, and don't do all this complexity of going into the landing on the moon, and then have to put your launch sources together again, and once again launch from zero up to whatever speed you want to go to Mars. So I think we need better definition on this. I don't think it's real clear right now, and I'm sure that Dr. Griffin and his people and Shana here can give us good information on that. But that's the way it appears to me right now, in answer to your question. Yeah.
The gentleman's time has expired. The gentleman from Ohio, Mr. Wilson, is recognized for 5 minutes.
Thank you, Mr. Chairman. First of all, thank you all for being here at the committee. It's an honor to be able to discuss the issues that are going on today. My question would be specifically to Senator Glenn, especially dealing with NASA Glenn and NASA Plumbrook in Ohio. Senator, I've been concerned for a long time as to why we don't get more credit for all the good work and the amount of jobs that are created, the economic development throughout the state of Ohio and the surrounding states with what goes on in Ohio. So my question would be is how can we ratchet up the attention on the good work that is done, and I'm sure it's done in many other states, but especially in our state of Ohio. And then secondly, and I would be interested in comments from the other two members too, Mr. Augustine and Dr. Zuber. That is, what can we do in Congress to help foster this much-needed economic growth from the NASA program?
A good question. I think it goes back also to Ms. Edwards' comment about the appreciation for Goddard out here. The NASA centers around this country are amazing centers of scientists and engineers and very, very capable people. Many of them really free-thinking on some new ideas that are really will redo the future for us. The center there in Cleveland is a good example in some of the areas of propulsion in particularly. They've led the way. And they have some of the finest engineers in the country there. They have an outreach program, but I don't know, the press just doesn't seem to pick up on this. I don't know whether the complexities of science get beyond the average press person pretty fast, or that's probably not a fair statement to make. But we need something like that, and I think, is it going to require another Sputnik? I hope not. But that may be the answer. I don't know. NASA up there at Cleveland, though, has they have a program of outreach for schools. They have a lot of visits by schools and trying to encourage our young people into math and science and technology. But it is a jewel. It's a fountain of information for that neighborhood, particularly in this area of energy and energy use. They had a program there some years ago called Redox, which I was quite taken with, and we got some money for it through the Congress when I was here. But it involved large amounts of electrical energy storage. If we could make one breakthrough in energy, that might be the one we would wish for, because you could then take all your every force of nature that we know how to put into electricity, we could then store it. So we could bring it back on stream during that 6 to 10 time in the evening when we need it most. And the theoretical part of that program was that we could get back about 70% of what we put into it, and it would take the output of a 1,000 megawatt power plant in non-peak hours. Now that would be enormous. We lost funding for that, and there were some complications with it. But those concepts are the kinds of things that our NASA labs work on all over this country, and do a great job in, and should get much more recognition for. Goddard, you mentioned earlier, Ms. Edwards, and the others also. Thank you.
Thank you, Senator.
I think your point is very correct. In this country, we tend to undervalue science as compared with most other countries in the world that I've visited. For example, in China today, of their 9 top leaders, 8 are engineers, and they understand what science can do and the importance of it. There's no question in my mind, but one of the highest return investments that this Congress could make is in basic research. There are many studies that support that. When it comes to getting a public that recognizes science and its importance, a lot of it comes back to our young people and trying to inspire them and help them. It's a long-term undertaking. But there's a great deal of anecdotal evidence that suggests that children, very young children, as I said, are very excited about science, and particularly about space. There's anecdotal evidence that we lose them by about 4th grade, that early, usually for 2 reasons, one of 2 or both. One is it's a father that tells their daughter that girls don't do math, and the second is that you have a phys ed teacher who's been told to teach math or to teach science. And that, unfortunately, is the majority of the cases, not the minority, an overwhelming majority. And so those are the things I think we have to solve.
Thank you.
Mr. Chairman, could I add to that just a moment?
Certainly, Senator.
Secretary Riley was Secretary of Education back in previous administration, and he was very concerned about the TIM study, Third International Math and Science Study. And it showed that our kids up to about the 4th grade, which is the figure that Norms just used, up to about the 4th grade are in the top 2 or 3 nations in the world of 41 nations that were studied over a 3-year period of time. Now, these figures are about 8 or 9 years old, or about almost 10 years old now, but I think they're still applicable. By the time our kids get out of high school, we're 2 or 3 from the bottom of 41 nations studied. And what happens in between there is exactly what he was talking about here. What we found when we had our commission, I headed that commission for over a year, what we found was that 25% of the math teachers in high school, just average across this country, were never trained to teach math. They're teaching out of field, as they say in education. And 20% of our science teachers were the same way, teaching out of field. Even more disturbing, perhaps, was the fact that 30% in both categories left the profession within 3 years, and 50% were gone in 5 years. They're off to AOL or Verizon or somebody that'll offer them a lot more money than they can make teaching. And so that's something, and what we're faced with is trying to do something about it. Is the thing is overseen. We call it an educational system. It's not a system. At that time, we had about 14,700 school boards in this country, each independent, each doing their own thing, with not much direction from above. And so, until we solve some of those problems and get that gap that occurs between the fourth grade and getting out of and graduating from high school, till we solve that, we're going to have big problems, I think, enticing people on into engineering and math and science and the scientific studies we'd like to see some of them entering.
Well, Mr. Augustine, through the Rising Above the Getting Storm, brought that information up to the current. And unfortunately, things have gotten worse. I think it's over 50% now of the math teachers in the middle schools have neither a certification or a degree in that subject, and it approaches 90% in the physical sciences. And so, as good as those teachers might be in teaching, if you don't have the core knowledge, it's hard to communicate that. And the reason it matters on a larger scale, Mr. Augustine said that only 4% of the public goes into the sciences, but not that other 96, though, need to have that kind of background to work at a higher and more efficient level. And so to get the jobs for today and tomorrow, so that there are 6.5 billion people in the world, half make less than $2 a day. We can't compete that way. We don't want to compete that way. And so that other 96% has to be at least the base education to compete at a higher level. And my time has expired. Your time has expired. And now Ms. Johnson is recognized.
Thank you very much, Mr. Chairman. I apologize for being late. I had another emergency call meeting. And I'd like to ask unanimous consent to have my statement put into the record.
Yes.
And greetings, Mr. Walker. You served this committee with tenacity and leadership as chair. And to our distinguished guests, I believe that space exploration has offered us more through its research than any other research that we've ever been involved in, with breakthroughs and products. And I'm very, very supportive of that continuing. And if I had to make a choice between research and immediate food, I think I would choose research and ask the churches to help us with food for a while until we found a substitute or something. I truly believe in research. I am so aware of the shortage we have in talent right now to help to continue it. And in my area, we have some excellent schools that Texas Instruments has made that possible with this extra funding. And they do well. That's only 20% of the total student body in the district. And I wonder, Mr. Valentine, am I saying that right? Mr. Augustine, what does Lockheed Martin do to further education and invest in your own future, frankly? That's what I tell instruments they're doing. Invest in your own future when you invest in education of our young people and our teachers.
I want to be careful when I answer that question because I've been retired from Lockheed Martin for 11 years, and so I can't speak for them today. But let me tell you...
what were they doing back then?
Let me tell you some of the things they were doing. One is the company established, with the help of the University of Tennessee, a program where we could award fellowships to teachers to come to the University of Tennessee, work with the Oak Ridge National Labs and other organizations summer programs to bring teachers up to speed with the latest developments. And this was all paid for by fellowships that the company gave. The company also has a number of local programs helping the Boy Scouts, the Challenger Center, the Girl Scouts, and community organizations of that type. And the company is particularly able to do that because it has plants or some kind of facility in almost every state.
Yes.
So, and in fairness, I have to say that Lockheed Martin is not unique in that regard. There are a large number of companies that have contributed a lot in that same respect.
I am so aware that we have so many teachers not really prepared teaching in these areas, and I believe that if some of the companies would offer some type of summer program for our teachers so they could see the environment and have an idea until we can find enough teachers that major in these areas. I am critically concerned about this area, and I've spent a lot of energy trying to see if we could change it. And I don't see the progress I'd like to see. And I don't think that the public understands the value of having these mines ready for this research and activity. And if I could elicit your volunteer service in helping to speak on these areas, I would appreciate that. I am very indebted to Senator Glenn for his contributions. And so is this nation and the world because of the contributions he has made. And I know that he continues to speak out, and I appreciate that, Senator Glenn. I thank you so much for what you've offered. But I know my time is about up, but I'm getting my sermon done here. My concern is our future, because I really do think that it is our homeland security and maintaining our competitive edge that's going to cause this country to survive as an independent nation. And we can do it, but it's going to take a lot of public education along with the students so that the public understands this need and have great expectations for our teachers and our students, because our students are not given that instruction to have those expectations. They take the easiest courses they can. It pains me every time somebody tells me they have a degree in political science if they're not going to get a PhD, or sociology if they're not going to get a PhD. And I think that my time is up, but America Competes has addressed some of this in law. We didn't get the funding we wanted, but at least the president signed the authorization of $33.6 billion, and that will help as the money comes. I don't see us coming out of a deficit until we have the skills to bring this money in. And I hope that you will spend time, all of you, preaching my sermon on my behalf and the nation's behalf, that we really do need this talent. And you have been in very key positions to understand what an important thing it is to have it. And I thank you very much. My time is up. I could ask questions all day, but I mainly want to get that out. Thank you.
Thank you, Ms. Johnson. I think we can all say amen. And I think it is appropriate that we complete our hearing with the last question from the gentleman from Texas who physically represents the Johnson Space Flight Center, and Nick Lamson.
Thank you, Mr. Chairman. And I apologize for missing some of your testimony earlier, but we're certainly proud that all of you came today and helped celebrate this 50th anniversary of this committee and NASA and all of the accomplishments. And one of the questions that, or one of the things that I certainly remember was 1957. I'm one of those that's old enough to have remembered listening to the beeps on the radio and to see what we responded to. And there are a lot of people who are starting to say today that we're hearing similar kinds of beeps, but they're coming in different forms, accomplishments of other nations and their successes. And in some of those instances, perhaps we should be more frightened with those successes in comparison to our own leadership capabilities and technological advances. Let me start with Senator Glenn and just ask, how should we view these growing space capabilities and plans of other nations? And then for everyone, what are your views as to whether we are on the verge of another space race? Can we make ourselves enter another space race, and how do we respond to it?
Thank you. There's a recent book, I haven't read it yet, by Fareed Zakaria, the international expert with Newsweek, I believe it is. And his theme in that, from a summary I read of it the other day, was that that we haven't laid down our mantle of leadership yet, but the trends are all wrong because other nations are now seeing what led this country into our successes, and they're putting more emphasis on education and research. As while we've leveled off in some of these areas, they're coming up. And that doesn't portend very well for the future. And so I think we're warned that we should get on with it. Earlier in the hearing, China's efforts were mentioned, and other nations too. And we, on one of our trips to China back some years ago, we met with Jiang Zemin, who was the president of China at that time. And I asked him then if they had considered joining our program with these 15 nations. And he told one of his staff people he wanted to look into that more. Well, nothing ever came from it. But I think how we were the world's leader. We are the world's leader in this area. And if we, by lack of support for these programs and for doing the research that's going to be the benefit to everybody here on Earth, I don't want to see us just seeing how far we can go in space, coming back, waving a styrofoam finger in the air saying we're number one or something. It seems to me that the basis for a space program on a long-term basis, support from our people, comes as they see research returns coming back that benefit them and their children in many, many different areas. The 5 that I mentioned earlier that NASA had special, the OBPR office had programs set up within to look in those areas. They seem to be the most likely to be productive at that time. So I think that it's not so much that we're just laying down, it's that whatever we're doing is not enough to keep us ahead of other people as I see it developing into the future.
Augustine?
My belief would be that we're not just in a space race. More importantly, I think we're in a science and engineering race. Not with any one country, but with a number of countries. Certainly the developing countries are committed to this area. You think of China and India and Brazil as leaders. We're all familiar with what China's been doing in space, including military space, and it's very impressive. I think that today we're benefiting from the investments that this committee brought about 10 or 15 years ago, investments in basic research. And it's always a question, as Senator Glenn said, when you have a lot of problems today, it's very difficult to invest in the future. But this nation could double or triple the investment in basic research, and when you looked at it, the overall curve of spending by our government, it wouldn't be the width of the line. That's the good news, is we spend so little today that we could greatly increase it without an enormous impact. So my highest priority would go to investing in basic research.
Thank you. I wanted to bring the issue of international cooperation, and particularly a project that we have been working on called the Alpha Magnetic Spectrometer, but I'm going to run out of time, and I want you to comment in another area, so we'll save that one. But if you'll both comment or discuss how NASA's aeronautics achievements have influenced the U.S. commercial aviation, maybe talk a little bit about what areas of aeronautics that you believe hold the greatest promise for advancing the nation's aeronautical capabilities and yielding future benefits for the U.S. commercial aviation industry. Both of you, if you don't mind. Senator Glenn, would you start?
Let me respond first to your AMS, Alpha Magnetic Spectrometer, because that's one of Dr. Zuber's colleagues up at MIT. And it's a very interesting thing. I think the committee should be aware of that one. Dr. Ting up there is a Nobel laureate, And after the superconducting super collider was canceled in Texas back some years ago, he picked up the idea of doing this same kind of research on the station. And could we put a huge magnet up there, about 15,000 pounds, and they've worked all this out. It's been over a period of time. He's put together a group that has raised $1.5 billion privately, 450 science engineers, 50 institutions in 16 countries, and they were promised on NASA that they would put this up. It goes up on the shuttle and then is mounted on NASA on the station, and makes its observations over about a 3-year period. This would be probably the most advanced particle research that's ever been done. And now he's been told that because of the cutbacks and because we have to stop the use of the shuttle, that project is now on, I guess you'd call it a permanent hold. It's at least being held. They won't say the thing is canceled, but there's no place to put it. It requires about a third of the cargo bay, and it's about 15,000 pounds to put up there. But it has some of the greatest potential of our scientific community, and was backed by all the scientific groups that I'm aware of. Dr. Zuber probably is familiar with that more than I am.
It's basically built.
Yeah, and it's built. It's ready to go.
It's built.
And they even put up a smaller version of it in 1998 very successfully to prove that this could be done. The truss is already there. And NASA and Department of Energy, which is the administrator of this, have spent many tens of millions of dollars, I don't know the exact figure, getting ready for this. Now it's canceled.
Well, Senator Glenn, let me just point out, if it's all right, in the authorization that this committee passed, that's pending in the Senate now, we authorized one additional flight for the AMS.
For AMS? Okay.
So hopefully we will be
Good.
able to proceed with that. The gentleman's time has expired, but if the witnesses would like to make any closing comments, we would welcome that before we will adjourn.
I would just say that it's my belief that investments in science are of enormous importance. Investment in our children, particularly in math and science, K through 12. This committee has taken a leadership role. Your chairman has been terrific in supporting these things. But unfortunately, you can't spend authorizations, and that's our challenge now.
Yeah, I'd just like to close by, again, thanking the committee for all of their support on the scientific side, the technology, and education. It's been crucial. We have fantastic young people in this country who have very bright futures. These are going to be the people who solve our problem in the future, and we need to get them engaged and get them going. And so if you could keep continuing your support of these endeavors, we'll be a better country for it.
My view is that the nation that leads in education and research, basic research in the future, will lead the world. I think it's that simple.
Well, thank you, all the witnesses. This has been a very thoughtful hearing. It's one that we're going to be able to ponder and be able to probably, or not probably, but we will try to incorporate into our future efforts here. And let me just close by saying that the record now will remain open for additional statements from members and for answers to any follow-up questions that the committee may have of the witnesses. And this hearing is now adjourned. Thank you.
I think that's what